So far we've learned two concepts involving average over an interval from A to B. So the first is the average value, so the average of what you are given, and the average rate of change. Remember, rate is the same as derivative, right? So this is the derivative. So the average of the derivative of what you're given. So we're applying the sum motion. So two ways we can find average velocity. So first thing that we could do is we could say the average value of the velocity. The average value of the velocity is going to be 1 over b minus, this is telling us specifically from 1 to 5. So it'll be 5 minus 1, and then the antiderivative from 1 to 5 of v, that's a v, v of t dt. So that's the first way. The second way that we can do this is to the average rate of change, so the average of the derivative. So I'm saying the derivative of what is velocity, and of course that's the position. The derivative of the position is velocity. So I'm going to say our x of t, so x of 5 minus x of 1 over 5 minus 1. So these are both the same thing here. You'll get the same answer for both of those. Now, two different ways we can find the average acceleration. So of course the first way is to do the average value of the acceleration. So you would have for this 1 over 5 minus 1 times the antiderivative from 1 to 5 of a of t dt. Now, the second way that we could do this is finding the average derivative. So the average of the derivative. So the derivative of what is going to be acceleration. So of course, the derivative of the velocity is acceleration. So we'll have v of 5 minus v of 1 over 5 minus 1. So both of these are exactly the same thing and give you the average value of the acceleration. So which one do you want to use? Well, which one we use is going to 100% depend on what we're given. If we're asked to find the average acceleration, but we're only given velocity, then we're going to use this formula. Meanwhile, if they ask us to find the average acceleration and they give us acceleration, we're just using the average value formula. So it all just depends on what information the problem gives us. All right, moving on. Here, so if I scroll down, it says, lastly, we can use the signs of position and velocity to determine if an object is moving away or towards the origin. So it has us. The particle travels along the x-axis such that velocity is given by v of t equals t to the 1.1 plus 2 cos of the 3t minus 3. So if I'm going to draw this out here, I'm drawing this line and it's telling me, so I have my origin right here. So here's my origin, and we know that at t equals 0, the position, so here, the position here when t equals 0 is -4. So this is t equals 0. And sorry, that shouldn't say 5, that should say 0. So at t equals 0, the position's at -4, so it's to the left of the origin. And then it wants us to say, is the particle moving towards or away from the origin at t equals 5? So my first thing that I'm going to say is I'm going to say, where's the position at t equals 5? And in order to do that, I'm going to say, and you can do this in your calculator, I'm going to take this, I'm going to say the position at 5. So x of 5 is going to equal the original position, so x of 0, plus the antiderivative from my initial time, which is 0, to the time I'm getting to, which is t equals 5. So from 0 to 5 of v of t dt. So that's the first thing that I'm doing, is I am computing what the position is at x equals 5. And when I do this, I'm going to get 9.720. So that means at time equal to 5, that my particle is somewhere over here at t equals 5. Now, the second part of this is we need to determine what the velocity is. So to determine my velocity, I'm just taking my v of t formula that I have right here, and I'm just plugging 5 in for t. Because remember, our velocity, we want to see if it's moving towards the origin, and right now the particle's to the right of the origin. And if my velocity is greater than 0, then I'm going right. So that means I'm going right. And if my velocity is less than 0, then that means that I'm going to go to the left. So velocity less than 0, go left. Velocity greater than 0, go right. So I'm going to find v of 5, and that'll be 5 to the 1.1 plus 2 cos, and 3 times 5, I'm just going to say 15 minus 3. So I'm just taking that and I'm plugging into my calculator. That's a 5 to the 1.1 plus 2 cos 15 minus 3. I got the 15 because 3 here times 5, my time is going to be 15. And when I do that, I'll get 7.8. So here, my velocity is greater than 0, which means that my particle is moving to the right. So currently, it's moving away from the origin. So my answer for this would be away. All right, to summarize, if v of t and x of t have the same sign, so if either they're both positive or they're both negative, then the object is moving away from the origin. And if you think about that, because here, if it's negative and velocity is negative as well, then it'll be moving left, which is away. Now, if v of t and x of t have different signs, So then the object is moving towards the origin. So the object will move towards the origin. All right. Then, so I'm going to erase all of this. And if I scroll down to the next sheet, then we have all of this, everything that we've covered so far today is going to be summarized there. All right, you guys have a problem set, so give those a try.